You age faster on a mountain. Everyday relativity explained. Right now, your head is older than your feet. By a tiny amount. But it's real. You are aging faster when you stand up, and slower when you lie down. Welcome to Everyday Relativity. We learn that time is constant. Tick-tock, tick-tock. Same for everyone. Einstein ruined that. Time bends with speed and gravity. Two clocks in different places won't agree perfectly. There are two effects to know. 1. Gravitational time dilation. Stronger gravity equals time runs slower. Weaker gravity, higher up, equals time runs faster. 2. Special relativistic time dilation. Move fast and your time runs slower compared to someone at rest. They pull in opposite directions. Put a super precise clock on the floor and another on a shelf. The higher one ticks slightly faster. Scientists have measured this over just tens of centimeters. Stand on a mountain and you age a teeny bit faster than at the beach. Lie down and you even out your own head-to-feet difference. It's tiny, nanoseconds per day, but over a lifetime the math stacks up. You've already met time dilation, even if you didn't know it. GPS satellites orbit high above Earth. Up there, gravity is weaker, clocks run faster. But they're also moving fast, clocks run slower. Net result? Their clocks would drift tens of microseconds per day without correction. That tiny error would turn into kilometers of position mistake. So GPS constantly fixes time to keep your maps honest. Another classic. Fly around the world with atomic clocks. Compare them when you land. They disagree by microseconds, exactly as relativity predicts. This has been done. Repeatedly. Even particle physics runs on time dilation. Short-lived particles called muons should vanish too quickly to reach the ground. But because they're moving near light speed, their internal time slows, so more of them survive to hit our detectors. Relativity, proven by cosmic rain. So, are taller people older than shorter people? By a whisper. The difference is so small you can't use it to win an argument, but the physics is true. Live your whole life on a high plateau versus at sea level, and the plateau person ends up older by a trace. What about airplanes? At cruising altitude, gravity is weaker, faster clocks, but you're also moving fast, slower clocks. Depending on direction and speed, those effects can partially cancel or swap dominance. Either way, the differences are microseconds, measurable, not meaningful for your birthday. Here's the intuition builder. Think of time as a stretchy fabric. Mass presses into it. Motion tugs at it. Clocks count how stretched their local patch is. Your brain experiences now, but physics whispers, your now depends on where and how you move. Quick home thought experiment. Imagine two twins. One lives at sea level. One lives in a high-altitude city. They video call every night at 8. They agree on the time, but their under-the-hood seconds are not identical. That's not sci-fi. That's the world we actually live in. Recap. Gravity slows time, height speeds it up. Speed slows time, rest speeds it up. Your head and feet don't age equally. GPS works only because we correct for both effects. Relativity isn't just for black holes. It's hiding in your daily routine. And the coolest part? All these differences are small until you need them to be right. Then they're everything. Love reality-twisting science like this? Subscribe. New curiosity every Sunday.